it's time for another math lesson with me, Jen. We're going to be working on third grade multiplication. So hopefully you guys have a good time. We're going to talk about arrays and tape diagrams, which are the two sort of most common Common Core. Ooh, that was a weird pun, but there you go. Methods that are used in the classroom to introduce it. All right, so what are we talking about today? Multiplication facts, times tables facts. Yes, we want students to become fluent in them, memorize, if possible, their multiplication facts. But before we get there, we need to get them to understand what they are. Like, what is a multiplication fact? Like, why is 3 times 2 equal to 6? Or 5 times 4 is 20? Or all these kinds of things. Okay. So how we're going to help students visualize what multiplication actually is to use repeated addition, honestly. And the two ways that you can do it is by using tape diagrams or arrays. And I think we're going to start with tape diagrams. We are! Okay, so in a previous video, I showed kind of a brief introduction of tape diagrams. They are used all over the place. Probably as early as 1st or 2nd grade. And I've even seen them through like in algebra courses. It's just a convenient way to quickly visualize groups, okay? So it's just a skinny rectangle, okay? They're partitioned or cut into pieces. Technically, they could be cut into different sized pieces, but for multiplication and division, which is our next video, they typically are having the same size piece because it's kind of that idea of fair share, equal share, that kind of thing. So here, if we wanted to show 5 times 4, what we're saying is we want 5 groups of 4. That's what this is saying, is 5 groups of 4. So I have my tape diagram. You'll notice that we have 1, 2, 3, 4, 5. So that is our pieces, partitions, if you will, 5 of them. And then what we've got is we have 4 in each. Now you could represent that 4 using dots, okay? No, totally fine. You could use it with actual numbers. That you're saying, you know, hey, I'm giving 4 in each box, okay? Well, we're asking how many total we have then. So if I think of this is actually addition. 4 plus 4 plus 4 plus 4 plus 4. So 5 fours. How much is 5 fours? So that's 20. Okay, now it's not efficient in the long term to think of multiplication as repeated addition. I mean, it's true, but this is why we have students memorize multiplication facts, because 5 times 4 is 20 is easier to remember than to add 4 5 times. However, this is the beginning of multiplication. This is how we show it. Okay, so let's try another one. Okay, so 6 times 3, we would have 6 boxes. We'll just pretend that's a beautiful rectangle. I know it's not. You know it's not. Just go with it. Okay, so we need 6. All right, and then we want to put 3 in each of these. So again, we could have students count them off with dots. We could have them just write the number 3. I mean, this is 3rd grade. We're talking about 8, 9-year-olds. So they probably are like, I can do this. All right, cool. So when I have all this together, what we're asking is how much is 6 3s? Okay, so 3 plus 3 plus 3 plus 3 plus 3 plus 3. That is, in fact, 18. So we are adding 3 6 times to get a total of 18. Okay, now, as much as you might be eye rolling at this idea, again, this is what students are going to be thinking about. Dots are actually fantastic for this, even though you might think, hey, it's easier to write 3. True, but it's easier to count sometimes. So sometimes for students, going 3 plus 3, that's 6. 3 more is 9. 3 more is 12. Sometimes it's easier to just actually physically count the dots as they're learning, okay? There are also touch points. Some of you might be familiar with touch points. If you're not, you can go and search it on the internet. But it's the idea that if you were adding 3, you would touch here as the students are counting. So if we go 3 and then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And every number has a touch point associated with it. So if that's something you're interested in, go look it up. But yeah, we're going to end up at 18. Story problems. Are there multiplication story problems? Of course. Absolutely. So we want to be able to have them solve it visually. So we've got this problem here. It says Gisela wants to give stickers to her friends. Oh, that's a nice friend. She has 4 friends and she wants to give each 3 stickers. How many total stickers does she need? Okay, so here we're going to represent her 4 friends as the 4 boxes, if you will, of the tape diagram. Okay. Slightly better, maybe not. Okay. So these are our 4 friends, and she's going to give 3 stickers each. So again, we could have her draw dots. We could write the number 3, whatever we're feeling. Okay. Again, some choice there. All right. And then we'd ask how many total. So if we count up all of this total, if we have our students count this up total, it's 12. And that's going to lead us to this amazing multiplication fact that they will work on, practice, memorize, all sorts of stuff. Okay, so that's the visualization of it. And then that's our math fact that they're going to work. Okay, interesting question you might want to ask your students. How would this diagram change if there were 5 friends? So if we had a 5th friend, then they could just say, oh, we just have 1 more box. And we'd have 1 more 3. And so here, that would just be, we'd add 3 more. So we would get the new fact of 5 times 3. What else do I have for you? Arrays. So let's talk about an array. Okay. Be careful when you go to Google arrays because there's a computer science definition of arrays. So if you're going to do this, I would definitely search 3rd grade multiplication arrays. And then what you're going to see is something like this, or some creative ideas you're going to see in just a minute. It's basically rows of circles. Could be X's, could be squares, could be heart, could be stars, whatever object you want to use. And it's showing the repeated addition. So for example, with the Gisela sticker problem, both of these arrays would represent what we just did. So this is basically representing 1 friend getting 3 stickers, another friend getting 3 stickers, another and another. Or we could have it aligned this way. Either way, what we're getting is we're getting sort of this grid of circles that's showing the repeated addition. And as you can see, this one is showing the repeated addition of 3 plus 3 plus 3 plus 3, or 4 plus 4 plus 4. Okay. So if we want to solve 6 times 3, we have the choice of doing, so let's talk about rows versus columns. So rows go across. So we could do 6 rows of 3. Or we could do 3 rows of 6. Okay. I would probably lean towards starting with the first number as the number of rows, but that's just me. So if I was going to do 6 rows of 3, and I'll also tell you my preferred shape are X's here. So I'm going to go, there's my first 3, my second, my third, 4, 5, 6. There you go. And again, visualizing that there is now 18. So that is how we're figuring out that there is 18. So 6 times 3 is the same thing as 18. Okay. What are 3 rows of 6? So this is saying that I have 3 rows. So 3 across, right? So it'd be 1 row of 6. Do that 3 times. Okay. Multiplication is commutative. That's the fancy name for saying that 3 times 6 and 6 times 3 is the same thing. Order doesn't matter. So there we have it. You could even have an activity where you have one partner have it go down, the other partner go across, count to make sure they understand that, hey, it doesn't matter which direction it is, it still works. Okay, yes, you can do story problems with arrays. This one is actually from the 3rd grade Common Core textbook. As Mrs. Tran plants 2 rows of carrots in her garden, draw an array that represents Mrs. Tran's carrots. Did I say 2 rows of 5? I hope I did. Use an X to show each carrot. So we're doing 2 rows. So a row goes across of 5. So we want our students to show what she's planted so far. We might even have some students say, okay, we already have 10. All right, great. Okay, so we might have that discussion, we might not. It didn't say to answer that yet, but they might already be there. Then it says, Mrs. Tran adds 3 more rows of 5 carrots to her garden. Use circles to show her new carrots. Excuse me. So here, if I do circles, still carrots, but we're just using a different shape because they asked us to and to show this new plant. And again, we may have students saying, oh, that's 15. All right, great. Okay, so it says fill in the blanks below to show how she planted the carrots. So first, how many groups of 5 did she have? So these are the X's. So we're not saying she had 10 5s. 10 is the total. This is saying how many groups of 5. So we had 2 groups of 5, and then we had 3 groups of 5 to make a total of 5 groups of 5. And then hopefully our students can see that we're at 25. Okay. As far as multiplication sentences, there's a couple different multiplication sentences. We could show the first planting. We could show the second planting. Or we could show the total planting. However we want to work with it. Okay. All right. Now, let's talk about some fun activities that you can do with your students. And again, the internet is a glorious place. It shows all sorts of fun stuff. So yeah, I just did a search for fun activities for multiplication. There were a ton of ideas. I thought these were kind of some of the most creative as far as what you may already have. So I think I mentioned before in a previous video about dominoes and how you could use them for like number bonds, but here it's multiplication. So if you remember the good old card game War, where each student pulls out a card, right? And you look to see who has the bigger number, and then they win both cards, and then you repeat. It's the same idea here, but with dominoes. So the idea here is that you would have students do the multiplication. So if I have a domino down there that has a 5 and a 3, that multiplication is 15 versus a 2 and a 4 is a multiplication of 8. So the 15 is going to win, and they take both. Okay. So yeah, super fun, easy. You could do it, just have it as a learning center activity or whatever. Okay. The next one I thought which was interesting is Guess Who. Do you remember the old school Guess Who boards that have like the little heads and stuff, and you're supposed to guess each character by a description? A lot of times you start losing those little pieces, and so here someone's recycled a set. And as you can see from this picture, they are putting the final product, and then they're basically grabbing cards and saying, do you have 2 times 4? So if you had the answer of 8, you'd put it down. And then you might say, okay, do you have 6 times 7? So if you had 42, you'd put it down. And you could either have them put down the whole board or a line across. You could also do this with bingo rather than having a Guess Who board. I'm not going to go out and buy Guess Who boards. However, you hit up thrift stores, you might find some with missing pieces, and you could recycle. So clever use of recycling. Those are not mine. I borrowed them from the internet from people who have better ideas than me. Okay, speaking of the glorious internet, here is one more great idea, Array City. I think this is so adorable. I cannot get over it. So you could have it on one of your bulletin boards. You could have them make up their own Array City, like on construction paper. But as you can see, what it is it's idea of an array already kind of looks like a building. And here they're just showing lots of different products. So if I take my attention down here, so this one looks like it's 6 by 3. So this is showing 6 times 3 is 18. And I bet that's probably what that card down there. And this next one is 2 times 6. So there is 12. And again, you could have it be really fun. Here it looks like each student may have had a black construction paper and then create their little city, and then they collected all of them to create a city. Craft, learning math at the same time, gotta love it. All right, that's it for multiplication, the beginning of multiplication. So for those who are thinking about, what about the harder multiplication, 2-digit numbers, 3 and 4-digit numbers? That is another video. So I will have another video on those types of multiplication problems. But for right now, we're keeping it simple. I hope you found something interesting today with me. And until next time, good luck. I hope that you enjoy learning math and practicing it with your students. So good luck. Have a good one. Bye-bye. Until next time.